Hello everybody. So right now we are going to study about Apollonius theorem. It's an important theorem using which you can find the length of median of a triangle when only the lengths of the three sides is given to you. So let us study the Apollonius theorem and then we will do a question on the basis of it. Let's start with it. So the theorem says that sum of the squares of any two sides of a triangle is equal to twice the square of half and half of the third side along with twice the square of the median bisecting the third side. So statement is a bit boring, but once I'll explain it, you'll be able to understand that quickly. So let's see the theorem. It means if I've got a triangle over here, suppose like this, suppose this is ABC, and suppose corresponding to the side BC, I'm making a median. This is a median. It means BD is equal to CD, right? Then as per Apollonius theorem, AB square plus AC square, AB square plus AC square, it will be equal to 2 times of AD square plus BD square. That is the Apollonius theorem. So in place of BD over here, you can take CD as well, because BD and CD, they are equal because AD is a median. I hope this is clear. AB square plus AC square is equal to 2 times of AD square plus BD square. This is the Apollonius theorem. Now the proof is pretty simple. If I do a small construction over here, I'm dropping perpendicular from here. See this thing? I'm dropping perpendicular. Suppose this is ABCDE, right? This is 90 degrees. So basically, if I take AB square, just see that patiently, if I take AB square plus AC square, what is that equal to? You see, in this right angled triangle, if I use the Pythagoras theorem, AB square will be AE square plus BE square. That is AE square plus BE square plus, if I see this right angle triangle AEC, in this AC square is AE square plus EC square. That is AE square plus EC square. Now you see over here, we have got 2 AE squares over here. So 2 AE square plus BE over here. See, in place of BE, we can write BD minus ED. BD minus ED we can do. So BE is BD minus ED. The whole square over here. In the same manner, in place of EC over here, in place of EC, we can write CD plus ED. We can write CD plus ED. The whole square. Now you see over here, this is 2 times of AE square. Now if you see the right angled triangle AED, over here AD square is equal to AE square plus ED square. That is the Pythagoras theorem. AE square plus ED square over here. Now in place of AE square, we can write AD square minus ED square. We can write AD square minus ED square. You see this thing. Plus, I can use A minus B the whole square identity over here. So we will get BD square minus 2BD ED, 2BD into ED plus ED square plus, over here I can use A plus B the whole square identity, that is CD square plus 2 CD into ED plus ED square. Now you see over here, we already know that BD and CD, they are equal because AD is the median. So BD and CD, they are equal. So you see 2BD ED, 2CD ED, they are equal and having opposite signs. So we can cancel them out over here. In the same manner, let's open up the bracket. You see this is 2AD square minus 2BD square, 2ED square, sorry. And then you see 2ED square is also there. So plus 2ED square. And then you see CD square is there and you have got BD square as well. BD square and CD square. They both are equal because BD is equal to CD. So we can write 2 times of BD square as well. So you see, plus 2ED square minus 2ED square can be cancelled out. So you see, this can be written like this, 2 into AD square plus BD square. So you see, that is the proof of the Apollonius theorem for you. That's a very important theorem when only the lengths of the sides of a triangle is given and you have to find the median. So you see over here, AB square plus AC square, AB square plus AC square is equal to 2 times of AD square plus BD square, or you can say CD square as well, because BD and CD are equal. So that is the proof of the Apollonius theorem. You can use it directly to find the length of the median. So let's do a small question on the basis of it. So you have got a triangle ABC. Let's make a rough figure as per the question. So you have got a triangle ABC. So over here, ABC, median is AD. AD is the median over here. Now you see over here, AB, BC, AC they are given. AB is 5 centimeter. You see BC is 12. But you see AD is the median. So this will be 6 and 6. And AC over here is also 12. So we have to find the length of AD. So you can use Apollonius theorem easily over here. So 2 times of AD square, 2 times of AD square plus BD square, that is equal to AB square plus AC square. So that is equal to 5 square plus 12 square over here. Now this is equal to, basically you see 25 plus 144, that is equal to 169 basically. If you take, that is 169. So from here you will get AD square plus 36, that is equal to we did a small mistake. This one is 9 basically. This one is 9. AC over here is 9. So let us put that equal to 9. That is basically 9. So AC is 9 over here. So you'll get 9 square. So that is 81 plus 25. 81 plus 25, that is equal to 106. So from here, AD square plus 36, that will be equal to 53. That is equal to 53. So from here, AD square will be what? 53 minus 36. And that is equal to what? That is equal to 17, I guess, over here. Yes. So that is equal to 17. So from here, AD will be equal to square root of 17. Although you will get 2 values over here, because you see this is a quadratic equation, but distance cannot be negative. So you'll neglect the negative value. AD will be square root of 17 centimeter. So this is the answer. So you have seen that Apollonius theorem is an important theorem if you want to find the length of the median directly. So that's all we needed to do in this video. Thanks for watching.